Hello, dear young minds. Welcome back to Physics Point. We are starting the third video of the chapter Gravitation. Already, you must have seen the starting two videos. If you haven't seen them, watch those videos, then come back to this video so that you understand all these things. So the link of the links are there in the description. All right. So in this video, we'll discuss about acceleration due to gravity and what is the concept of weight, and we'll see this derivation also, expression. What is the expression for acceleration due to gravity? We'll have an idea about that. Then we'll have a discussion on concept of weight, then changing of weight from place to place. All right, all these details we'll discuss in this video. So I welcome all of you once again for your beautiful physics channel Physics Point, and my name is Shrikant Bashetti. Let's get started. All right. So as you are saying here, the heading, what is acceleration due to gravity? You need to have idea what is this acceleration due to gravity. There is some word called acceleration, and there is one more word called gravity. Acceleration due to gravity. For example, imagine you are standing here. Okay, you are standing here. This is you. Okay, smiling beautifully. Now a stone is dropped on your head from this much height, for example. Now definitely this stone will come and it will hit your head, and maybe you will have less effect. You will have less effect. Okay, because it is dropping. It is dropped from less height. No. Now, for example, you are standing here. Okay, the same person, you are standing here. Don't think that the head has become bigger one. Now the stone is dropped from here. Now it will also come and hit you. Now here there is more effect. No. Here there is more effect. Okay, now initially when it was dropping, its initial velocity was 0. It was dropping from initial, it was not thrown, it was free. It is called free fall. What is this? This is called as free fall. Free fall means dropping freely. I mean dropping with 0 velocity. Dropping with 0 velocity. Okay, that is called as a free fall. Free fall means it is not thrown, it is just dropped. Okay, free fall means dropping it. It is also starting with 0 velocity. Both are starting with 0 velocity only. This is also starting with 0 velocity. This is also starting with 0 velocity, and it is having more effect. It will cause more harm to your head. No, it will come and hit you and causes more harm, more effect, and it will come and hit you and causes less effect. Why? Why it is happening? Because here it is hitting you with more velocity. Correct? No? It is hitting you with more velocity. Here it is hitting you with less velocity. Correct? Now what is happening here is, when this stone is dropped, now initially its velocity is 0, now it is increasing as it is coming down. The velocity is increasing. Correct? Now it has got very less time, so that's why the velocity increase a little less. I mean little less as in very little, the velocity has increased. Now look here. Now this stone is dropped from this much height, it has got more time, the velocity has increased more here. Are you getting my point? Here also it is increased, but it is increased a little. It is increased less only, but here also it is increased, but it increased more. That is a difference, right? All right. So whenever we are dropping a stone from some height, for example, this is the earth. Okay, here we have earth, and we are dropping a stone from some height, means this is a stone. Okay, now initial velocity is 0, but as it is coming down, look at this, as it is coming down, if you take 3 points here, for example, this is a first point, this is a second point, and this is a third point. If you take its velocities v1 here, v2 here, and v3 here, you can easily tell that this v1 is less, v2 is again more, and v3 is highest. Are you getting my point? As we are coming downwards like this, the velocity is going to increase. This is very important concept. If velocity is increasing means, what does it mean? Velocity is increasing. That means the acceleration is coming into picture, right? Acceleration is coming into picture. Correct, no? So what do you mean by acceleration? Acceleration is a rate of change of velocity. Correct? Rate of change of velocity is called as acceleration. Now for a freely falling body, the velocity is increasing means there is an acceleration. Why that acceleration is coming? Why that acceleration? Why acceleration is coming? Tell me. The acceleration is coming due to gravity, due to gravitational force, due to gravitational force, hence the name acceleration due to gravity. I hope the concept is quite clear now, what I am trying to say. Alright, so whenever a body is falling, its velocity is increasing. If its velocity is increasing, means it is getting some acceleration. That's what is known as acceleration due to gravitational force, or we just represent it as acceleration due to gravity. And symbol for acceleration due to gravity, acceleration due to gravity, whatever it is there now, the symbol for it is a small g. Capital G is universal gravitational constant, that is a different issue. In universal law of gravitation we have seen that, but acceleration due to gravity, that value is g. Alright, small g. This is very important. I hope you got to know what is this acceleration due to gravity. If you want to write the definition, you can write down, but it won't be proper for us to write the definition for this. For a freely falling body, you can write down, for a freely falling body, velocity increases. So we get acceleration. I told you what is freely falling body. So we get acceleration. If velocity is increasing, means we get acceleration, and that acceleration is due to gravity. It is because of gravitational force. So that is acceleration due to gravity. Clear? So if somebody is asking you what is acceleration due to gravity, you should be able to tell, for a freely falling body, velocity will be increasing, so we get acceleration, and that acceleration itself is known as acceleration due to gravity. Alright, you got to know the source of acceleration due to gravity. Moving forward, let us look for some expression and all. What is the expression for this acceleration due to gravity? Let us have idea about that. Alright, so before that, you know about Newton's second law, right? Newton's second law. So you know about Newton's second law and definition and all. Law, what is a statement, and after that we get one equation called force is equal to mass into acceleration. Alright, force is equal to mass into acceleration. Now same thing can be applied here. For example, there is a body here, okay, here is the earth. Alright, now there is a stone here, here is a stone. Now if it is falling, means why it is falling? Because there is some force acting. So the formula for force should be always a mass into acceleration. Now instead of this acceleration, what will come? Acceleration due to gravity will come. That's why we call it as F is equal to mg. Alright, I hope everybody is understanding. This is the Newton's second law, F is equal to mass into acceleration. And I told you this acceleration due to gravity is, the symbol is a g. So that's why instead of this a, we'll be using g. By using this, we are going to derive this expression for acceleration due to gravity. Alright, now for example, this is the earth surface, okay, this is the earth, and on the surface also, if you are keeping one stone here, still it is getting attracted, no, downwards. That's why it is sticking to the earth, right? So this is getting attracted. Definitely the force formula should be mass into acceleration, and mass into, instead of this acceleration, we keep it as acceleration due to gravity. So whatever this g is there, this is acceleration only. It is not something else. It is acceleration only, but it is due to gravity. So that's why we keep it as mg. Alright, fine. So moving forward for this expression, so how this expression comes, let us discuss. For example, this is the earth, okay, this is the earth surface, this is the earth, alright, and this is having mass me. Me means mass of earth, and on this I have placed one object here, and let this mass be m. Alright, now what is the distance between their center? Just observe this center and this center. Earth is very big, okay. So from this point to this point, it is a radius of the earth, correct? This is the radius of the earth, and this is radius of the body. Now compared to this radius of the earth, this radius will be very small, correct? No, so whatever radius is here, this radius will be very small. So that's why what we do, completely we show that this distance from center to center, this entire distance is r. So r means what? What is this r? R means the radius of earth. So that is the distance between the earth and that body. Alright, so just to keep it, according to universal law of gravitation, what does universal law of gravitation says? Universal law of gravitation says this F is equal to g into mass of the first body, that is me, and mass of the second body, that is m, and divided by distance between their centers, here to here. Look at this, here to here. this distance is r, so that's why we are going to keep it as r square. All right, so instead of this mg, what we can keep, listen to me very carefully now, this is very, very important. Now this body is there, no, this body is getting attracted downwards, right? That's why it is sticking to earth. So with what force it will be attracted? With force mg. So it is attracted with some force, and definitely this force is equal to what? Mass into acceleration, and acceleration is nothing but acceleration due to gravity. All right, I hope it is clear. So instead of this f, I can keep here mg. So mg is equal to what it comes? G me m divided by r square. Here m and m they get cancelled, and we get one equation, that is g is equal to, small g is equal to capital G into me divided by r square. So this is the formula for acceleration due to gravity of earth. Look at this formula, this is constant, this value is constant, that is 6.674 into 10 to the power minus 11 Newton meter square per kg square, and mass of earth is also constant. It is not that every day it is going to change, and radius of earth is also constant. If all these are constant, means this is also constant, right? This should also be constant. So that's why when you substitute, okay, when you substitute these values, substitute G, me and r, if you substitute all these values, you are going to get this acceleration due to gravity as a 9.8. This numerical value will be 9.8. This is constant for earth, okay, and as it is acceleration, the unit is going to be meter per second square. Very, very important. All right, so similarly you can take this value to be approximately equal to, approximately, for numerical purpose we can use 10 meter per second square, so that the numericals becomes quite easy for us. All right, what is the value of acceleration due to gravity of earth? The value of acceleration due to gravity of earth is 9.8 meter per second square, or it is approximately taken as 10 meter per second square. You observe this formula, no? You observe this formula keenly. You observe this. So if you want to find out acceleration due to gravity of any body, you have to take g, then mass of that body divided by radius of that body squared. All right. For example, if you want to find out acceleration due to gravity of moon, if you want to take acceleration due to gravity of moon, so what will be the formula? So I will write it as gm. Gm means what? Acceleration due to gravity of moon. So that is like equal to g into, it becomes mm means what? Mass of the moon divided by rm square. Okay, please observe all these words. What is this gm? So gm is nothing but acceleration due to gravity of moon. All right, so what is this g? You know about this g, this is universal gravitational constant. What is mm? Mm is mass of moon, mass of moon. What is this rm? Rm is radius of moon. All right, so like that, any body is there, definitely you can get to know the acceleration due to gravity of that body. Okay, any body. For example, acceleration due to gravity of sun means, what is the formula? G into mass of the sun divided by radius of the sun, then square. So this is the acceleration due to gravity of sun. All right, fine then. So before coming to this concept of weight, so let me explain this concept of weight. Then before that, I need to talk about this acceleration due to gravity of moon. And it is found out that this acceleration due to gravity of moon is there, no? Its value is 1/6 of acceleration due to gravity of earth. Okay, please try to understand this. So this will take us to concept of weight. I will come to that also. So what are the meanings here? What is a gm? Gm is acceleration due to gravity of earth. All right, so 1/6 you know. So what is this g? So g value is acceleration due to gravity of earth. Sorry, this is gm is acceleration due to gravity of moon, and ge is acceleration due to gravity of earth. Okay, it is found out experimentally as in I mean with the calculations. So gm is equal to acceleration due to gravity of moon is 1/6 into, so ge value is 9.8, so that is like 6 ones are and 3 is a carry, 6 6 36, then 2 is a carry, then 6 3s are. Alright, so acceleration due to gravity of moon is going to be 1.63 meter per second square. Like that, every body has its own acceleration due to gravity of moon. Its own acceleration due to gravity. For example, I want to find out acceleration due to gravity of for example, any star or any body or any celestial body, for example Jupiter. Okay, Jupiter is one planet, no? What is the formula? Please tell me. Acceleration due to gravity of Jupiter is equal to universal gravitational constant into mass of Jupiter divided by radius of the Jupiter square. Alright, so this is how we are going to find out acceleration due to gravity of any body, and I have given you two examples, that is acceleration due to gravity of Earth. Its value we calculated, as in we got to know due to this constant, that is 9.8 or 10, and I talked about moon also, as it is a natural satellite of Earth. I talked about that also, and its value will be 1/6 of acceleration due to gravity of Earth. Alright, so I hope the concept is clear. Now let us discuss about that concept of weight. So how does this weight comes into picture? The symbol of weight will be W. Alright, so the concept of weight goes like this. Okay, what is the meaning of weight? Weight is nothing but, it's the force. It is the downward force. It is the downward force with which an object is attracted towards Earth, or towards any celestial body, or towards moon, towards Jupiter, whatever it may be. As we are on the Earth, we are keeping this as Earth. Okay, it is a downward force with which an object is attracted towards Earth. All right, Earth means you can write it as any celestial body here. All right, no problem. It is a downward force with which an object is attracted towards Earth is called its weight. Write down this definition, I will explain. For example, this is the Earth. Okay, this is the surface of Earth. Here is Earth, and there is an object kept here. Alright, so this object is getting attracted towards Earth, no? That's why it is attaching to this. So this force, so whatever this force is there, what is the formula for this force? Mass into acceleration due to gravity, already I told you. So this force itself is known as a weight. So weight is equal to mass into acceleration due to gravity. So that's why weight changes from place to place. For example, this mass won't change. This mass is constant. At starting of the chapter only I told you. So whatever this mass is there, mass remains constant. Mass remains constant throughout the universe. Mass remains constant throughout the universe. Okay, it do not change. Okay, mass of an object, mass on Earth is equal to mass on moon also. The mass is not going to change, because mass means amount of substance. All right, but weight will change. Okay, weight changes from place to place, as in from Earth to Sun to Moon to some other star, some other planet and all. Alright, why it is changing? Because the formula for weight itself is W is equal to mg. Okay, this m will remain constant. How about this g? This g value will be changing from place to place. Alright, so on Earth it is 9.8 meter per second square, but on moon we just calculated it is 1.63 meter per second square. So that's why it will be changing from place to place. Alright, so that's why you should be careful about this. Alright, so let us take a question. Here. Mass of a body is 10 kg. Find its weight. Find its weight on Earth and moon, both on Earth and moon. Okay, all right, let us do that. So mass is given already. So weight on Earth. Okay, weight on Earth, let us write it as We. So weight on Earth will be, formula will be mass into acceleration due to gravity of Earth, definitely. All right, so what is the value of mass? 10, acceleration due to gravity of earth is 9.8, so it is going to be 98 Newton. Please remember the unit of weight is Newton. What is this? Unit of weight. What is the unit of weight? It is going to be Newton. Why? Because weight is nothing but force. I told you. Look at this. What is the weight? It is a downward force it is. So force means it must be Newton. Alright. So now what is the weight on moon? Okay. Weight on moon. Weight on moon is equal to mass into acceleration due to gravity of moon. Alright. So instead of doing like this, you can do it like this, no? I mean, I'm just right now I'm giving you the complete details. Afterwards we'll have the shortcut. Mass into acceleration due to I mean gravity of moon means it is 1 by 6 times of acceleration due to gravity of earth. Correct, no? So what it becomes? It becomes 1 by 6 into mass into acceleration due to gravity of earth. Correct, no? So mge already you calculated, that is 98. So what I am trying to say here is weight of any body on the moon is equal to 1 by 6 times of weight of the same body on earth. This is very, very important. Alright, so if you want, I can write it in the form of a sentence. What is that? Weight of a body or weight on moon. Weight on moon is equal to 1 by 6 times into weight on earth. Alright, so whatever weight is on the earth, so you have to make 1/6 of it to find out its weight on moon. Alright, so just to calculate this, so it becomes 1 by 6 into mge means what? This is the weight on earth only. Alright, so that becomes 98. So that is 6 ones are 3 is the carry, 6 6 are 36, 2 is the carry, then 6 3s are. Alright, so what it becomes? It becomes 16.3 Newton. So this is the weight on moon. Alright, so please put it in a box. These concepts, how these are, no, it is not like you are going to understand them in one shot. Alright, you have to keep aspiring for them. You have to keep looking for them so that you get to know that. Alright, now immediately if the question is asked like this, okay, if the question is asked like weight of a person, weight of a person on moon is 100 Newton. Okay, find his weight on earth. Find his weight on earth. Alright, so we know the relation, right? So what is that? Weight on moon is equal to 1 by 6 times of weight on earth. We know this concept. Let us substitute them. So weight on the moon is 100, and that is equal to 1 by 6 into weight on the earth. Let us keep weight on the earth there. So it becomes a weight on the earth is equal to 100 into 6, that is equal to 600 Newton. So a body is going to a body which is weighing 100 Newton on moon will be weighing 600 Newton on earth. Alright, so it is reverse, no? If it is 1/6 means it is 6 times more. Alright, so I hope the concept of the weight is also quite clear. Weight means, what is this weight? Weight is nothing but it is a downward force with which an object is attracted towards earth. Alright, so that's why it is Newton. So let us summarize whatever we have discussed. Okay, so this went a little fast. What is acceleration due to gravity, dear children? The acceleration due to gravity is coming as a body is falling, its velocity is increasing. Its velocity is increasing means there must be an acceleration, and that acceleration is coming due to this gravitational force. That's why the name acceleration due to gravity. Alright, fine then. Moving forward, what is the expression for acceleration due to gravity? We did all this derivation and we got to know that acceleration due to gravity of any body is equal to universal gravitational constant into mass of the body divided by square of its radius. Alright, for example, we want to find out the acceleration due to gravity of moon. It becomes g into mass of the moon divided by radius of the moon square. Alright, same is the case with acceleration due to gravity of sun. G into ms divided by rs square. Same is the case with Jupiter. Alright, I gave you all those examples here, and I gave you one more data. So what is that? Before getting into concept of weight, I gave you the concept that acceleration due to gravity of moon is 1 by 6 times of acceleration due to gravity of earth. Why it is 1 by 6 times? Because mass of the moon is less, no? The mass of the moon is less and radius of the moon is also less. So that's why this value is going to be less for moon. Like that, according to the mass and according to the radius, this acceleration due to gravity will be changing. Alright, so I gave this hint Then afterwards we started to discuss about concept of weight. I told you what is the meaning of weight, all right, and I gave you an expression. So this is the formula for weight. Weight is equal to mg. So what is this m? Mass. So this mass is going to be constant throughout the universe, and this g value is acceleration due to gravity. So it changes from place to place. So that's why this weight will also be changing from place to place. Weight changes from place to place because weight formula is mg. Then I gave you some examples. If mass is given, we can calculate weight. If weight is given, we can calculate mass. All right, interdependently we can do all those things, and I gave you example of earth, moon and all. All right, so here are some homework for you. Okay, look at this, how beautifully these are designed. What is the acceleration due to gravity of Jupiter? You know that acceleration due to gravity of Jupiter is equal to g into mass of Jupiter divided by rj square. All right, you get all this data of mj and rj from the Google, and you find out its answer. Mass of a person is 40 kg on earth. What will be his mass on moon? Okay, so look at this, just think about it. What is the answer? If you want, comment down in the comment section, so I will make a separate video on this homework. So weight of a person on a certain planet is 100 Newton. If his mass is 50 kg, find acceleration due to gravity of that planet. Okay, so these three questions are there. Please make it sure that you are solving them to strengthen your topic. All right, we have come to end of this video. Make it sure that you are liking the videos, sharing the videos and subscribing to the channel, because these are the things which motivates us to shoot all these videos for you. All right, I sign off from this video, and I will be meeting you in the next video with much more important concepts of physics. Thank you very much. Have a good day and bye bye.